Now, a divergent CC boundary means a divergent boundary between two continental plates. Divergent, of course, means they're pulling apart. Continental plates, of course, are continents. And in this case, they're either Iceland or the African Rift Valley. There's also one of the Red Sea that formed the Red Sea. So in Iceland, we see that there's on one side, there's the European plate, and on one side is this is the European plate here, and this is the North American plate. And this in the middle is some granite that was once lava that came up when those two plates pulled apart, and that lava has subsequently hardened to form rock. So there, of course, are places in Iceland when that rock is still lava, and those are the volcanoes in Iceland, but this particular place has the rock. The San Andreas Fault is an example of a transform boundary, and the San Andreas Fault has two continental crusts that are moving not toward nor away from each other, but instead are sliding past each other. When we look at the San Andreas Fault, you see that this part of California is attached to the Pacific Plate and is moving northwest. This part of California is attached to the North American Plate and is moving southeast. And since they're moving in opposite directions, this entire line, which we call the San Andreas Fault, is where you experience the California earthquakes. Now, we also can talk about the type of stress that's at each of these boundaries. Convergent boundaries are where things move together. The type of stress is called compression. Divergent boundaries are where things pull apart. The type of stress is called tension. And transform boundaries are where things go past each other. The type of stress is called shearing. Now, we also can name the type of fault that occurs there. Convergent boundary, another name for a convergent boundary is a reverse fault. Another name for a divergent boundary is a normal fault. And another name for a transform boundary is a strike-slip fault. It's the same exact thing, just a different name. When we talk about faults, we're looking at hanging walls and footwalls. So the hanging wall is the part of the fault that you could hang I guess this is a person hanging on to a rope, or it could be a swing or whatever. You'd hang it from this part. And the footwall is the part of the fault that you would put your foot on, like this guy is, to climb. And depending on how they interact with each other, you either have a normal, a reverse, or a strike-slip fault. So the normal thing to happen would be for this hanging wall to move down, just like normally you'd move down a slide in a playground. Normally the hanging wall moves down. We call that a normal fault. And in order for that to happen, the hanging wall moves down, the footwall moves up. In order for that to happen, you can't squeeze them together. You've got to separate them. And we call that divergence or tension. The reverse of that is when you push them together and the hanging wall moves up. Or you could say the footwall moves down. When the hanging wall moves up, it's called a reverse fault. And that happened because of compression. If they move past each other, where one moves, let's just say forward, and one moves backward, we call that a strike-slip fault. And you can see in this picture, it doesn't matter which is the hanging wall or the footwall, so they just drew it flat. The hanging wall and the footwall doesn't matter because nothing's moving toward or away from. So we just drew it, with a perfectly perpendicular angle there. But we just said that this one on the western side of this picture here is moving toward us, and this one's moving away from us. So we say that in a, where am I? Convergent boundary, we have the stress called compression, the fault is called a reverse fault, and the hanging wall moves up, the footwall moves down, like we just saw here. Reverse fault, compression, squeezing together, moves the hanging wall up. In a divergent boundary, you have tension being pulled apart. We call that a normal fault. And in this case, the hanging wall moves down, the footwall moves up. So you see we pulled it apart, and this hanging wall moved down, the footwall moved up. In a transform boundary, the stress is called shearing. It's a strike-slip fault, and they move side to side. They neither move toward nor away from each other. They just move side to side. You also want to know there are three types of folds. This is called a syncline. See how it's shaped like a smile. This is called an anticline. See how it's shaped like a frown. And this is called a monocline. The important thing here is that this part and this part are perfectly parallel, although they're not at the same level. So syncline, anticline, monocline. They all happen because of compression. You can't get rocks to fold by pulling them apart. You have to push them together. There are also three types of mountains. A fault block mountain would be kind of jagged and craggy. A folded mountain would be a little bit softer and smoother. And a volcanic mountain, of course, is produced by volcanoes, by magma. Now, at the folded mountain, the type of stress has to be compression, which means it's a convergent boundary, which means it's a reverse fault. That's all coming from the previous slide. I just looked up that to fold something means I have to have compression. Another word for compression is a convergent boundary. And another word for a convergent boundary is a reverse fault. A fault block has to be tension, like I showed you before. And that's got to be a divergent boundary. Tension occurs at a divergent boundary. The type of fault at a divergent boundary is called a normal fault. This is everything you need to know in one nice, easy screen, if that makes you happy. And happy studying.